In this video, we look at the basic rule of integration and the standard rule of differentiation. This is a recall, basic rule of differentiation called the power rule, differentiation of a polynomial. For example, if you are given y is equals to kx raised to power n, then the derivative of y with respect to x, which is dy dx, is equals to k times the power n, and you reduce the power by 1. For example, if you have a y is equals to 3x raised to power 7, then dy dx, the derivative of y with respect to x is the same as 3 times 7, and you reduce the power by 1, so that you get 3 times 7, 21, x raised to power 6. This is the derivative or the gradient function of the curve y is equals to 3x raised to power 7. That means that if you are, let's say, to plot this graph, hypothetically, let's say this is the graph at maybe a certain interval, y is equals to x raised to power 7, then it means that you can find the gradient of a tangent to the curve at any point using the gradient function dy dx is equals to 21 x raised to power 7, the gradient function. So on the other hand, if you look at integration, the standard rule of integration, and we should think of the indefinite and of course the definite integral. If you consider, let's say, y is equals to kx raised to power n, then the integral of y with respect to x is the same as k x raised to power n plus 1. Here you increase the power and you divide by 1, and you divide by the new power, that is n plus 1. You increase the power n by 1 and you divide everything by n plus 1. And you add a constant c, because this is an indefinite integral. So when you go to definite integral, for example, if you want to integrate y, the same y, kx raised to power n, from, let's say, a point A to point B with respect to x, then you should get k x raised to power n plus 1 over n plus 1 from A to B, And if you were to expand, you should get is equals to k b raised to power n plus 1 over n plus 1 minus k times a raised to power n plus 1 over n plus 1. So this is the definite integral, and note note that definite integral, note that the power n here must be not equals to -1, must not equals to -1. Otherwise, if it is equals to -1, then we shall have the integral of, say, the integral of, for example, integrate with respect to x 1 over x. 1 over x. Note that this is actually the integral of x raised to power -1. Note that our n, the power of n, is equals to, the power of n is equals to -1. And this will be the same as the natural integral, the natural logarithm of the absolute value of x plus c. The natural logarithm of the absolute value of x plus c. So when n is equals to -1, then we have that the integral of 1 over x should be the same as the natural log of the absolute value of x plus c. For example, if you integrate 3 over x, note that this is the same as the integral of 1 over x with respect to x times 3. And this will be the same as 3 times the natural log of absolute value of x plus c. So for the sake of absolute, not absolute, for the sake of definite integral, suppose you want to integrate 3x raised to power 4 with respect to x from 0 to 2, from 0 to 2. Note that this is the same as saying you want to find, let's say, assume this is the curve y is equals to 3x raised to power 4. Let's assume that curve from 0 to 3 will look like that, x, y. So this integral, this should be 2. This integral is similar to the area below the curve from point 0 to 2. And this will give us 3 x raised to power 5 over 5, and x is from 0 to 2, which will be the same as 3 times, instead of having x here, we have 2 raised to power 5 over 5 minus 3 x now will be 0 raised to power 5 over 5. And of course, the second part will reduce to 0. And so this one will be the same as 2 raised to power 5 is that 2. So we shall have 96. 3 times that 2. 96 over 5. 96 over 5. So those are the power rule, what we call the power rule of integrating a polynomial function, and which is so basic.